Hello everybody, I'm Connor Massey and I'm here to teach you some grade 12 advanced functions. Today we are solving a trigonometric function word problem and I'm going to help you learn how to properly approach and solve a question in this category. Before we begin the question, I'm going to quickly explain how radians work, as this is a 12U trig question, therefore radians will use rather than degrees. We know from grade 11 that one full circle was 360 degrees. Rather than cutting the circle into tiny bits that make 360 small components, radians work by the relationship between the circumference and the radius. So, the radius is the distance from the center to the outside. It was found that this length fits along the circumference, half the circle, 3.14 and then many decimals times. This value is known as pi. So, 3 radians and just a little bit more fit along half the circle. This is known as pi, as I stated. This means that for a full circle, it must be twice as much, or 2 pi. Radians are then measured as the fraction that it makes around the circle. For example, around here is 1/6 of pi. So if you did 6 more of these, you would get to pi, as shown there. All the other values, for example, half, as shown here, is just simply 1/2 of pi. And so on for all the fractions around the circle. The sample question I have today looks like this. It states that a contestant on a game show spins a wheel that is located on a plane perpendicular to the floor. He grabs the only red peg on the circumference of the wheel, which is 1.5 meters above the floor, and pushes it downwards. The red peg reaches a minimum height of 0.25 meters above the floor and a max height of 2.75 meters above the floor. Sketch 2 cycles of the graph that represents the height of the red peg above the floor as a function of the total distance it has moved. Then determine the equation of the sine function that describes the graph. Right after reading the question, you should go over it again, extracting what the problem is asking you to do and the key information. I'll highlight what the problem is asking me to do in green and the key information in red. In this case, the question is asking for us to sketch 2 cycles of the graph that represents the height of the red peg above the floor as a function of the total distance it has moved. Also, it's asking for us to determine an equation of the sine function that describes the graph. Knowing this information, we then know to search through the rest of the question for the components of a sine equation in order to create the sine graph and sine equation. So, looking back at the top, we realize that it's on a perpendicular plane to the floor, meaning it's standing vertical, and the red peg is on the circumference of the wheel, which, importantly, is on 1.5 meters above the ground. We then get the information that it is pushed downwards, meaning it'll be a negative sine function, and the red peg reaches a minimum height of 0.25 meters and a maximum height of 2.75 meters. I have now summarized this information from the question above. Now that you have the information required to solve the problem, there is a simple outline to follow in order to solve what it is asking for. First, it is best to begin your sketch with the information given directly from the question. Next, you should look over the sketch to see what is still missing. Then, you should calculate for the missing values given the extra information in the question. Finally, fill in the rest of the graph and create the equation using the solved variables. So, to start, we can begin with a simple showing of the graph, knowing that the x-axis is going to be labeled total distance, and the y-axis is going to be labeled height. Also, from the question, we know that the max height is 2.75 meters, so we can plot that down. And the min height is 0.25 meters. Also, it states that the red peg starts at 1.5 meters. From this information, we can see that 1.5 meters looks approximately halfway between 2.75 and 0.25. We can confirm this by seeing that 1.25 meters and 1.25 meters is the distance between both of them. This means that the amplitude will be 1.25 meters and the vertical shift will be 1.5 meters. Also, it states that the red peg is pushed downwards, so we know it starts here and then begins going down. Looking at this, we now know that all we need to do in order to be able to graph the sine equation is label the x-axis and then plot all the points, knowing the path of a negative sine graph. In order to label the x-axis, we need to know what the period of this sine graph is. We know that the x-axis is impacted by the total distance, and therefore one whole period will be when the red peg gets back to its original position, as shown by a sine graph where it reaches back to its start position. This is going to be 1 period. Now this is also going to be the whole distance of one circle. We know that because the height from where it starts, the path will start by going down, as shown here in this first quarter. Then it'll make its way back up, as shown in this second quarter. Then it'll make its way to the very max point, and finally back down to the middle. And its total height is reflected by its total distance throughout this whole path. Because we know that the peg will travel one full revolution around the circle, we can solve for the period by calculating the circumference of the circle. We know from grade 10 that circumference is equal to 2 pi r. The radius we don't directly have, but we can piece it together from the information given in the question. We know that this point is 1.5 meters above the ground, and the minimum is 0.25 meters above the ground. This will be the same for the middle of the circle as well, meaning that the difference between the two will also be 1.25 meters, and therefore the radius is 1.25 meters. Then we can plug this in and get that the circumference is going to be 2.5 pi. I left this value with 2.5 pi in it to keep it as an exact value, although it should be noted that this is not a measurement of an angle like radians are. In this case, it is measured in meters, which means that it's not an angle. 2.5 pi, in this case, does not mean that it's going 1 1/4 rotations, as 2.5 pi would
Radians would be.
It just means that the circumference of the circle is a little bit larger, and therefore the peg travels 2.5 pi meters. So now we can apply this knowledge back to the sketch of the graph and plot that one period is going to be 2.5 pi. Now we have enough details and information to create a more accurate sketch of the graph. Now, when creating the final graph, we must consider the domain that it will occur in and also get more accurate x-axis points. So, in the question, it said that the domain was for 2 cycles. And also, we know for accurate x-axis points that every quarter of a sine function, every quarter of the period, there is going to be an accurate plot on the graph that we know. Therefore, we're going to divide the period by 4. And that will allow us to plot these additional points. We know that the domain of 2 cycles means that it's going to be 2 periods, so we can simply double this and show the next cycle of the graph, which will end at 5 pi. Again, in meters, which you also must label both axes correctly. So, for the next, the x-axis points, so we know the period is 2.5 pi, and if we divide that by 4, which with fractions equals 2.5 pi over 4, which then can be simplified to 5 pi over 8. Therefore, every 5 pi over 8, there is going to be an accurate point, and it'll be increasing by this much each time. So, after this, we can plot 4 equals points, and then plot all of the positions on the graph. So, it starts at 0, because its distance to begin with is 0, it hasn't moved. Then it will move 5 pi over 8, and then so on. When everything is put together, the graph should look something like this. It shows that the red peg will start at a height of 1.5 meters and travel 5 pi over 8 meters until it reaches its minimum height of 0.25 meters. It then travels another 5 pi over 8 meters to get to its original height, and 5 pi over 8 more meters to reach its maximum height of 2.75 meters. Then once again it travels 5 pi over 8 meters to get to its original height. This then happens again in the second cycle. We also must recall that the question asks for a sine equation that represents the graph. To begin this, we can take the information from the graph and insert it into the components of a sine equation. To start, we know that the a value, or the amplitude, is the distance from the middle to the max height, as shown here. So, we know that the middle is 1.5 from earlier, and that the max is 2.75. Therefore, the amplitude is the difference between those two. We also know that it has a negative value because the sine graph begins downwards. Next, we can look for the h value, which means any horizontal shift or phase shift. We see that the sine equation starts directly at 0, therefore there is no shift. Next, we can look for the k value, which is the vertical shift of the graph. So, we can see that the graph middle point is right here, 1.5, where the red peg starts. Therefore, the vertical shift is 1.5. Next, we can solve for the b value, remembering from grade 11 that b equals 2 pi over p. Usually in grade 11, you would remember this to be 360 degrees over p, but because it is grade 12, we know that 360 degrees is also equivalent to 2 pi radians. So, the period we know as one full cycle of the graph, which ends at 5 pi over 2. Therefore, the period is 2.5 pi. So that turns out like this, which then can be simplified to equal 4 over 5. And therefore, that is your b value. Now, we can insert all of these components into the equation to get your final answer. So y equals the a value, which was determined as negative 1.25, sine the b value, which is 4 over 5, x, and there is no h value, and it is 0, and then plus the vertical shift, which we determined as 1.5. So this is your final answer. Electronic engineering is a discipline of electrical engineering that is responsible for designing, testing, and supervising the manufacturing of electronic devices. When it comes to electronics such as radios, Wi-Fi devices, and wireless phones, signals traveling as a wave must have the correct properties in order for the device to function. To create and understand the property, the wave can be shown by a trigonometric equation or graph. The trigonometric equation of the wave signal must be considered when designing a product.